Alright, so in this lesson we're going to be talking about perpendiculars as well as distance. So before we've talked about two lines being parallel using angle relationships. Now we're going to find the distance between a point and a line and also find the distance between parallel lines. Some new words we want to be familiar with: equidistant. So let's look at a key concept here. Equidistant meaning equal distances away. So the distance between a line and a point not on the line is the length of the segment perpendicular to the line. So this segment right here, if we're looking at the distance from line AB to point C, we want to make sure we get the distance perpendicular from C to line segment AB. So this postulate, if a given line and a point not on the line, then there exists exactly one point through the line, one line through the point that is perpendicular to the line. So if we have line M here in point P, there's exactly one line, no more, no less, that is perpendicular to M and goes through P. So let's look at this example. A certain roof truss is designed so that center post extends from the peak of the roof, point A, to the main beam. Construct and name a segment whose length represents the shortest length of wood that will be needed to connect the peak of the roof to the main beam. Now the construction part is going to be something we'll go over in class. We'll talk about constructing perpendiculars to a line. But to get that distance from a line to a point on the line, we do need to construct a perpendicular to line segment RS that extends out to point A. So this red line they've drawn for us right here. We want now a second point not on the beam that's equidistant from R. So in order to construct this line segment AB to be perpendicular, we need to find this point that is an equal distant from R and S. Since R and S are both on this line segment, this point out here needs to be the same distance from each of those points. So the measure of line segment AB, this right here, represents the shortest length of wood needed to connect the roof to the main beam. So any other distance is going to be too long. So go ahead and try this question. You can pause the video and answer it on the site. So let's take a look at another example. We have line S graphed for us. It contains points at 0, 0, and -5, 5. We want to find the distance between line S, so this line, and this point V, which is at 1, 5. In order to do that, we're going to need to find, first of all, the slope of line S, and we're going to need to find the slope of the line that goes through 0, 0, and -5, 5. So we get the change in y, which is essentially up 5. We get the change in x, which is essentially to the left 5. So we have 5 over -5. The slope of this line is -1. We can write the equation knowing the slope, and we have a point at 0, 0. So let's go ahead and write that out, which is remember y equals mx plus b, and you have 0 for your x and y values, and you have -1 for your slope. We can use that all to find that b is equal to 0, and we put that into our equation. We get y equals -1x plus 0, so we end up with y equals negative x. Our second step is we want a line perpendicular to S that runs through 1, 5. So if we go back to our original line here, it needs to be perpendicular, so it's got to be this line. Well, could have drawn that a little better, but it's got to be this perpendicular line that goes straight from the point to the line. Notice I curved it a little bit, but we want it to go straight there. Alright, so in order to do that, we have to remember that the slope of our new line is going to be 1. And it goes through at the x value of 1, it goes to the y value of 5. Why did we choose 1? Because that is perpendicular to line S, which has a slope of negative 1. So we plug that in. 5 equals 1 times 1 plus b. So essentially subtract 1, we get 4 equals b. So y equals 1x, or just x, plus 4 is our line that's perpendicular to S and goes to that point. Now we want to figure out where line S, which remember was y equals negative x, and also our perpendicular line, which was y equals x plus 4, we need to figure out where those cross. So I'm going to set the two y's equal to each other. We know that y is the same as y, so let's set negative x, this expression, equal to x plus 4, the other expression. And we're going to get, if we subtract x from both sides, we'll get negative 2x equals 4. Divide both sides by negative 2. We get x equals negative 2. The point where x equals negative 2, we can put that back into our equation to either one. Since it's the same point, we get y equals negative 2, so y equals positive 2. We can be assured that those two lines cross at negative 2, 2. So if we name that point z, negative 2, 2, now we just need to find where the the distance between that point we initially wanted to know, 1, 5, and the point we just found, 2, 2. So we'll use our distance formula. D equals the square root of differences between the x's squared as well as the distances between the y's squared. So the distance between the x would be negative 2 minus 1 squared, plus the difference between the y's, we could say 2 minus 5 squared. Doesn't matter which order, because even if it's negative, the square root will get rid of the negative. So we end up with negative 3 squared, or 9. We end up with, again, negative 3 squared, or 9. So we get the distance is radical 18. And if you want to, you can approximate that. Square root of 18 is the exact value, or you can estimate that to be about 4.24, being the distance between those two, the line and the point. So let's see if you can do that on your own. Pause the video and see if you can find the distance between this line N and the point B at 3, 1. Now the next key concept we want to look at here is the distance between parallel lines. The distance between two parallel lines is the perpendicular distance between one of the lines and any point on the other, because once we find a point on that other line, it doesn't matter where. If I have two lines parallel here, once we get a point on this line, I can easily get a perpendicular to the second line. So we're just going to find that line segment's distance. That'll get us the distance from this line to this line. So Theorem 3.9 tells us in a plane, if two lines are each equidistant from a third line, then the two lines are parallel. So if we have two lines that are equidistant from a third line, then these two lines have to be parallel, because if they aren't, then you're going to have some crisscrossing going on. So find the distance between the parallel lines A and B whose equations are y equals 2x plus 3 and y equals 2x minus 1. So as you can see, we're going to need to solve a system of equations again to find the endpoints of a segment that's perpendicular to both A and B. From their equations, we know that the slope of A and B is 2, because if you look here, m equals 2 for both lines. So sketch line P through the y-intercept of line B, which is 0, negative 1. That's just convenient for us because we have a point on B, and we want it to be perpendicular to both lines. So our first step, we want to write an equation out for line P. Since P is perpendicular to both those lines with a slope of 2, we know P has to have a slope of negative 1/2. Next, we want to use the y-intercept of line B, which is 0, negative 1. That's going to be the endpoints of one perpendicular segment, of the perpendicular segment. So using point slope form, we can put 1/2 in for the slope and the y-intercept of that line in for the point. And we get y plus 1 equals negative 1/2 x. And finally, we just solve for y by subtracting 1 from each side. We have our slope there and our y-intercept. So step 2, now we're going to determine the point where lines A and P intersect, because we know where B and P intersect. So line A has an equation of 2x plus 3, we're given that, and line B has this equation. So let's just set them equal to each other. Add 1 to both sides, subtract 2x from both sides, and we're going to get 4 on this side equals, let's see, negative 1/2, and plus negative 4/2 is going to give us negative 5/2 x. So we're going to get 8 when we multiply both sides by 2 equals negative 5x. And finally, x is going to equal negative 8 over 5 when we divide both sides by negative 5. So that's our x value. Our y value is going to be y equals 2 times that x plus 3. So when we plug that in, y equals negative 16/5 plus what's essentially 15/5, and that's going to simplify to negative 1/5. So our point lies at x is negative 8/5, y is negative 1/5. So negative 8/5, negative 1/5 becomes negative 1.6, negative 0.2. And we're just going to use the distance formula to find the distance between the 2 points. The point that we know is on B and the point we know is on line A. And our answer, you should get 1.79. I know I'm going a little fast because I'm running out of time, but make sure you pause it, make sure you understand what's going on here. Finally, one last question here. Find the distance between the parallel lines A and B, respectively. And with seconds to spare, this concludes our lesson on perpendiculars and distance. As always, thanks for watching, and if you have any questions, feel free to ask me.